Kia ora Year 9. It's been ages since I made any videos with some trickier problems, so I thought I'd do a really nice Don Stewart task about the surface area of cuboids. I just want to warn you though that the challenge level on this one is many levels of hot chili pepper. So it's a maths video, so if you want to, you can count the chilies and tell me how many you can find in the picture, but this is pretty full on. So it starts off looking innocuous, but this is what we've got. We've got a cuboid and it's got a square cross section and the length is 1 centimetre longer than the height and the width. And we're given the surface area, we have to figure out the dimensions of the cuboid. So let's back up to what we all learn in Year 9. So a cuboid is a shape. Let's see if I can draw it roughly. My cuboid's not going to look very nice, but imagine that those lines are straight. So there we go. It's basically like a box of tissues or a book, and it's got 3 dimensions. And it doesn't really matter which way I write those dimensions. I'm going to call this side the width, this dimension back here I'll call the length, and this dimension back here I'll call the height. Now students always ask if it matters which one's which, and it really doesn't as long as we label them clearly. So the volume of that cuboid we can find by multiplying the 3 dimensions together. It's L times W times H, and the unit will be usually centimetres cubed or metres cubed. For example, if the dimensions were, I don't know, I'm going to make some numbers up here. So 6, 2, and what have I got here? It's a bad cuboid, 6, 2, and we'll call that 7. Then the volume of that would be 2 times 6 times 7, which is 84 centimetres cubed. And we're going to be working backwards in the problems that we're doing, but we're not going to be working with the volume. We are instead going to work with the surface area of a cuboid. So let's get rid of this stuff and go back to the main one. What can we say about the surface area of a cuboid? Well, a cuboid has got 6 faces. So this front one has got one that's the same behind it, and we can't see it in that diagram. But the surface area of the cuboid is going to be made up of 3 pairs of areas. So it's going to be 2 times WH. Then it's going to be 2 of this one. So 2 lots of LH. And lastly, if you can imagine or just think about the one here on the top of the cardboard box and on the bottom. Right, so that gives me plus 2 times, what have I got left? LW. So now let's go back to the problem. So far this problem doesn't look too bad. So we've got a cuboid and it's got a square cross section. The length is 1 centimetre longer than the height and the width, and the surface area is 66 centimetres squared. Right, so notice that now that I'm back to dealing with area, my unit is centimetres squared, not centimetres cubed. So we have to figure out what its dimensions are. And there are 2 ways to do this. The first way is using guess and check or trial and error. And that's not a bad place to start. But pretty quickly, you're probably going to want to move to using algebra. So I say that because if we use guess and check, we never can be sure that we haven't missed out on some solutions. But when I do this using algebra, we can be confident that we've found everything. But I just want to show you the skills that we're going to use in this video so that you don't freak out when the algebra gets a bit heavier. So we can do trial and error, and that's one way. Or we can do this. We can start by naming a variable and then figuring out an expression for the surface area. We use that information to form an equation, and then we're going to have to do a couple of mechanical algebra things. We're going to need to expand lots of brackets and solve a quadratic equation. So we don't usually teach this in Year 9, but you're welcome to go ahead and learn this if you're ready for it. And some of you already know how to do that. The last thing that we have to do is we have to figure out if our answer makes sense. And there's the first typo in the video. That should say interpreting the answer. So let's go back to question 1. Oops, that's question 4. So they get harder. There are 4 of them. They're all a bit the same in structure and a little bit different. Right, so when we're solving a problem like this, it's a good idea to start by defining something. So what am I going to say here? Well, first thing I'm going to do is I'm going to draw that cuboid out again, but a wee bit bigger. and we know that it's got a square cross-section. And the length is 1 centimetre longer than the height and the width. So as I've drawn it, I'm going to let this side have length x, and I'm going to let this side, so this is a square, this is also going to be x, and the dimensions of this are going to be x plus 1. Okay, and if I were doing that really nicely, I'd say let the, what am I going to start with? Let the width be x centimetres. So what can I say about the surface area? Well, the surface area is equal to the following. I've got the front and the back face, so that's x squared times 2. Then, what's next? Well, I've got this side here, and that has dimensions x plus 1 and x. So its surface area will be x times x plus 1, and there are 2 of those. Lastly, I've got the top and the bottom faces, right? But we know that they're going to be the same, so that's 2 more lots of x times x plus 1. But basically, each of these bits is the area of a rectangle, or in this case, of a square. So once you've formed that, we know that that surface area is going to equal 66 centimetres squared. So if you are confident with quadratic equations, you might be able to go all the way from here right through to the end of the problem. And that's great. If you're not, I'm going to work through this pretty slowly, so you can either watch with me, or you can try a little bit and then watch a bit more, or you can speed ahead and check that you've figured it out. Right, well, the first thing I need to do here is to clean up this big, long algebraic expression. So I'm going to expand out some brackets and collect up like terms. So we have 2x squared plus 2x squared plus 2x plus 2x squared plus 2x, and that equals 66, right? So here I'm just doing my usual expanding brackets like this. Now I'm going to collect up my like terms, and I've got 6x squared altogether plus 4x equals 66. Now, if you're watching this and you don't know how to solve a quadratic, this is probably a good place to go and jump on Education Perfect and figure them out, or ask me or Mr. Cox, or get someone to help you with it. But when we solve a quadratic, we work like this. We almost always want to have 6x squared plus 4x minus 66 equals 0. And now we can divide everything through by 2. That gives us 3x squared plus 2x minus 33 equals 0. But this is not the first kind of quadratic that we learn how to solve, because it doesn't have x squared, it's got 3x squared. So again, if you're getting a bit lost, a good place to stop and ask one of your friends to help, or a teacher, or go and figure it out on EP or on Khan Academy. So here's what we're trying to do here. We want 2 numbers that multiply together to give me 3x squared. So let's try this. 3x times x. That's going to give me 3x squared. Now, we want 2 numbers that multiply together to give me negative 33, but that will let me have a middle term of plus 2x. So let's think of factors of 33. Well, the most obvious ones are 3 and 11. Or we could also do 1 and 33. So let's try and muck around with these to see if we can factorise this quadratic. Well, let's see if I put the 11 here, what happens. Put 11 here, put 3 here, and we'll put in a plus sign and a minus sign. Well, what does that give me? Well, it doesn't give me the right answer, right? Because here I'm going to have plus 33x minus 3x. That gives me plus 30x. So that didn't work. Now we're getting rid of far too much stuff. Let's see what might be a better choice here. Well, let's go back to trying the 3 and 11, but in a different order. If we have 3 here and minus 11 here, let's see if that works. So I've got 3x squared, then I've got minus 11x coming from here plus 9x. So it feels like I'm getting closer, but not quite. And lastly, I've got minus 33, but that's still not right, but it's getting close. The problem with this is that that would give me 3x squared minus 2x minus 33 equals 0. I don't want minus 2x, I want plus 2x. So there's one small thing that I can change. So let's get rid of all that. And some of the mess in here. Oh, that was cool. There we go. Let's get rid of the minus and the plus and see if we can change it a little bit. So we want to have plus 2x. Here I've got 11 times x. So if I put a plus sign in here, my pattern's going to work out. I'm going to have plus 11x coming from here, and I'm going to have minus 9x there. Now to solve that quadratic and finally answer the problem about a cuboid, here's what I've got to do. Either this is equal to 0, or this is equal to 0, because 0 times anything gives me 0. So to solve a quadratic, what we're doing is taking each factor and asking when it will be equal to 0. So let's first look at this one. 3x plus 11 equals 0. Does that make any sense? Well, that would give me 3x equals negative 11, and x is equal to negative 11 over 3. But remember what we're trying to do. We're trying to find the length of the side in the cuboid. So it doesn't make any sense. We know that our x value has got to be positive. So we're going to hope that the other factor will work. And look, it does. The other factor is x minus 3 equals 0. So this is saying that when x is equal to 3, we think the surface area should equal 66 centimetres squared. So let's go all the way back to the start and see if we were right. Okay, so let's pop some numbers on now. So instead of x, we're going to put on 3. So if this side is 3, this will be 3, and this one will be 4. And the surface area will be 2 lots of 9 plus these green ones that are now purple, 2 lots of 12 here, and the yellow ones up the top, 2 more lots of 12. So what does that give me? 18 plus 24 plus 24. So that's 18 plus 48. So look at that. Happily, it works. Otherwise, I wouldn't be making this video. So the surface area we've found fits the condition, which is that it's 66 centimetres squared. Now, that was a really long video. So what I'm going to do is just show you the next 3 questions. And I'm just going to pause it. And I'll come back and do some answers for those later on. But they follow exactly the same pattern. So here's the second one. This cuboid has got dimensions that are consecutive numbers. So for consecutive numbers, here's your clue. You might want to use x, x plus 1, and x plus 2. And you're going to end up with a quadratic, a bit like the one we had in the first one. Okay, here's the third question. So for this one, it's got a square cross section, and the height is 1 centimetres less than the length and width. So you might want to start with x for the square cross section. Your dimensions will be x, x, and if the height is 1 centimetres less, the height will be x minus 1. So we're again going to set up an expression for surface area, collect up all my like terms, and end up with a quadratic equation. And here the surface area is 80 centimetres squared. And the last one is very similar. The cuboid's got a height that is 1 centimetres more than the width. So we'll start with the width, we'll make x. The height's going to be x plus 1. And the length is double the height. So it's 2 times x plus 1. And as before, we're going to say the surface area is made up of the area of the 6 faces. And this time that's equal to 72. So there you go, 3 more problems for you to try. Send me an email when you've had a go at them and you think you've figured them out. Thanks for watching.